I'm delighted to be with you today to launch the first webinar in the BlockW IOB AI Impact series. As Claire said, it will be AI Fridays for the next month. Today, we start with digital sustainability, then AI and health, the AI Act, how it works, and AI and ethics. But it's my great pleasure today to welcome our keynote speaker, Ioannis Kolaxis, who is Director at Accenture Technology, Sustainability and Innovation. He's a Senior Technology Architect. Ioannis also is based in Greece and focuses on green software innovations, helping customers measure and reduce software carbon emissions. He's an inventor, published widely, and a great read, I'm sure he'll reference this today, is his Green Software book. And he's recognized nationally and internationally, receiving many awards, including Inventor of the Year for 2021. We're certainly starting on a high note. I'd like to say just a little bit about BlockW. As Claire said, it's a female-led, not-for-profit organization whose mission is to create awareness of and increase access to emerging technologies for women and girls. And how do we do this? We do it through advocacy, strategic partnerships and collaboration by building networks, offering learning events and research and resources. BlockW empowers women and girls in this digital age. And today's webinar is in essence about empowerment for organizations and all individuals in financial services. It's about responsibility for and leadership of digital sustainability. Ioannis will make a call to action today, and we hope that his presentation will encourage you in your own organizations on an individual basis to take and empower yourselves to take control of something that often we all feel is something out there and nothing to do with us. Digital sustainability is becoming increasingly crucial, as we know, for financial services. And understanding and addressing our own IT footprint is essential, as it contributes significantly to scope 2 emissions for financial services. So the task ahead is clear. We need to embrace energy efficiency technologies, transitioning to renewable energy sources. Adopting green software and AI practices will not only reduce environmental impact and cost, but will also, which I think is really important, drive innovations and resilience. Ioannis will show us that by leading these efforts, financial services can play a pivotal role in combating climate change. I know Ioannis wants to make this presentation, his presentation, interactive. So please feel free to ask questions or comments, make comments during his presentation, and then there will be a question and answers after his presentation. Ioannis will speak for about 40 to 45 minutes, and then, you know, as I said, please feel free to ask questions during his presentation, and if not, we'll go to those questions at the end. So we're really pleased to have you here today, Ioannis, and we look forward to your presentation. And thank you very, very much for being with us today. We appreciate it very much.
Thank you, Professor O'Connor, for this opportunity to present, for the invitation. Hello, everyone. I'm very happy to be here today and talk about computers and what their impact is on the environment. We use computers on a daily basis, either for personal reasons or for our work. We use them right now to connect and have this meeting through Zoom. We connect through mobile phones, tablets, or our laptops. We use the network to exchange data and broadcast that session. And at the very end, there are the data centers that run Zoom and power that whole session. all these computers and the data networks that enable us to have this session today consume electricity. In order to generate that electricity, many times we have power plants that burn fossil fuels like coal, gas, and diesel. And by burning all these fuels, we emit greenhouse gases that contribute to global warming. Therefore, our computers, our digital world is not as clean as many of us think of, but they significantly impact the environment, contributing to global warming. By the end of the session, you will all be familiar with how our digital world impacts the environment, contributing to global warming. My name is 𝐁𝐢𝐠𝐢𝐭𝐚𝐥 Kolaxis. I am based out of Athens, Greece. And as Professor O'Connor introduced me, I focus on helping our customers measure and reduce the environmental footprint of computers and software in general. I've started programming when I was in primary school. Back then, I used a computer that had a green screen to write code in BASIC. And although that code looked green, it was quite different by what we mean today by green software. I speak regularly at conferences, spreading the word about green software and digital sustainability, aspiring to bring a change in our industry in how we design, develop, and operate software applications. As most of you may already know, data center electricity has increased by 4 times in Ireland, from 5% in 2015 to 21% in 2023. Data centers demand more electricity than the power plants can supply, therefore leading to quite a few challenges, such as increased prices in electricity. In West London, they face similar challenges. They cannot build any homes in West London because the data centers installed in this area consume all the electricity. It will take more than a decade until they build new power plants and extend the power grid to be able to accommodate additional houses in that area. Therefore, the environmental problem of excessively using digital technology is real and affects people around us. It affects our daily lives. With the recent introduction of generative AI, most of you may have already used ChatGPT or similar Gen AI chatbots, which consume a lot more of electricity compared to conventional artificial intelligence or enterprise software applications that most of us use on a daily basis. As you can see here, we expect the power consumption due to artificial intelligence to increase significantly in the next 4 to 5 years. There is a problem, a challenge of energy scarcity, with the power plants worldwide not being able to keep up with the increased demands from data centers. Most of you may be familiar with Mark Zuckerberg, who leads Meta, which was formerly known as Facebook. He recently gave an interview talking about the challenges that Meta is facing. They have been investing heavily in artificial intelligence in the past year, and although they have plenty of funding to build new data centers that will support their AI operations, the main challenge is that there is no sufficient energy to power these plants. They would have to build their own nuclear plants right next to their data centers so that they can power these data centers with their own dedicated nuclear plants. However, due to the regulation that is there for building new power plants, it will take them more than a decade to plan, get all the necessary permissions, and then build a power plant. Therefore, what prevents them from making the breakthroughs that they aspire in the space of artificial intelligence is the lack of energy, which can be quite impressive. However, energy scarcity is not the only challenge that we are facing. The environmental impact of our digital world has multiple dimensions. The other dimension is the one of the carbon emissions. We continuously see a rise in the carbon emissions coming from data centers, data networks, and the end user devices like laptops, tablets, and mobile phones. Back in 2020, IT systems contributed 4% of the global carbon emissions. That was the amount of carbon emissions contributed by Japan at that time. However, we expect that these carbon emissions coming from our digital world will reach 14% in 2040. Most interestingly, this prediction comes from an older research that was published before the introduction of generative AI and large language models like ChatGPT. Therefore, we will likely see a higher rise in the carbon emissions due to the rapid adoption of generative AI. From our experience working with multiple customers in Accenture, we've seen that especially for the financial services industry, including banks, most of the carbon emissions come from the data center operations. This is usually around 35 to 45% of the total carbon footprint of a bank. Therefore, by focusing on the digital sustainability problem, we can make a significant impact, a significant contribution in reducing the carbon emissions coming from banks and other organizations in the financial services industry. Whereas in other industries which are more capital heavy, like the oil and gas sector or in mineral extraction companies, there the contribution of the IT systems tends to be smaller, with the industry part of these organizations having the most significant contribution to carbon emissions, as you can all imagine. Therefore, if there is one thing that you need to remember, is that data center operations account for a significant portion of the carbon emissions coming from banks. Therefore, that's a huge potential for all of you to take some actions and reduce that footprint. Besides the energy scarcity and the carbon emissions related to the use of computers, we also have a water consumption issue. Most of the data centers that power our applications are built next to lakes or rivers, and they use that water to cool all the servers that they have in their data centers. In the whole process, water is consumed. Water is consumed while cooling all these servers in the data centers. There has been a recent study showing that whenever we use ChatGPT for a casual conversation, we consume half a liter of water. Half a liter of water just to play with ChatGPT and ask some simple questions. And there is one more dimension of the environmental problem related to our digital world, which is related to the e-waste that we produce. Whenever we throw away one of our computers, laptops, tablets, or mobile phones, these usually end up not being recycled, not used in any way. They end up in junkyards, polluting the environment. According to a recent study, we are disposing 1,000 laptops every second. That's also a huge environmental problem. And due to the sheer number of devices globally, this is one of the most significant impacts of our digital world. It's time for a quick quiz. We briefly mentioned that we all use devices like laptops, tablets, and our smartphones to connect to the internet and use applications. While using our applications, we exchange data with some applications running on data centers. And these data centers run the backend applications that power all this interaction with the applications. Can you guess which one of these three components has the highest environmental impact? You can also provide your answer in the chat. Is it devices, data networks, or data centers that have the highest environmental impact? And the winner are devices. As I hinted previously, we have a high number of devices. We have more than 30 billion devices globally. And the second one are data networks. Due to the shift from fixed line networks to mobile wireless networks, there has been an increase in the electricity consumed by data networks. For every gigabyte of data that we send over wireless mobile networks, we consume significantly more electricity than with fixed line networks. And then the third one, having the least environmental impact, are data centers. Although we mentioned these at the beginning, and they do consume huge amounts of electricity, they have the smallest environmental impact. Let's start with devices which have the highest impact. 8 billion people worldwide own 30 billion devices. If we zoom in, most devices are smartphones, followed by smart TVs, personal computers, and tablets. Each person owns 3.6 devices on average. This varies by region, ranging from 1.5 devices per person in the Middle East and Africa to 13.4 devices per person in North America. All these devices have something in common. They run software applications. And we develop and operate these applications. How could we somehow reduce the environmental impact of these devices? But before we answer that question, let's take a look at the environmental impact of a typical smartphone. The data you see here are about Apple's iPhone 6. And as you can see, by the time you buy a smartphone, it has emitted most of the carbon expected throughout its lifetime. 85% of the carbon comes from the production of that smartphone, 3% from its transportation from the factories to the shops, and only 11% comes from customer use, assuming that the end user will keep it for 3 years. if we don't keep that smartphone for 3 years, but change it and buy a new one every year, then we incur a high environmental cost, most of which comes from production and transport. But if we extend its lifetime to 4, 5 years or more, then we spread its carbon emissions over time, reducing in that way its impact. What could we do to extend the lifetime of smartphones? Before we answer that question, let's first try to understand why we buy new devices. I remember buying a new smartphone a couple of years ago, and after a while, it stopped receiving new software updates. I was stuck with an old version of the operating system. Whenever I tried to install a new software application on my smartphone, I would get an error message that my operating system was too old to support the latest mobile applications. Therefore, although the hardware was working properly, my phone was working just fine, I couldn't download and install the latest mobile applications. And I owned that phone for less than a year. After a while, I had to get rid of that phone and buy a new one so that I could install the latest and greatest mobile applications. The same thing happened to me with other devices. I had a tablet and a TV. Both of them worked perfectly fine. The hardware had no issues, but after a while, I couldn't install the latest updates. Therefore, one of the reasons that we are forced to buy new devices is that the software does not support older devices. And this is quite relevant to many of you because financial institutions like banks release applications like e-banking applications that we use in our daily lives. So one way you can contribute to reducing that environmental impact is by influencing your organizations to support older devices when releasing updates to your mobile applications. Therefore, the way we can prolong the lifetime of devices is by building mobile applications that run on older devices, supporting older operating systems, and therefore requiring minimal compute and memory. If we do the opposite, as it is quite often the practice, requiring that all the users have the latest and greatest smartphones, then we are contributing to this environmental challenge that we are facing nowadays. Therefore, we can be part of the solution just by influencing our organizations to support older devices. I know this may sound theoretical to some of you, so I would also like to provide a real-world example. Facebook Lite and Instagram Lite are both applications that have been developed by Facebook, by Meta, for countries with a low income, where the citizens there cannot afford to buy the latest and greatest smartphones. Therefore, they released these light versions, Facebook Lite and Instagram Lite, that work with older smartphones that were released 15 years ago. These are the Android phones that were, people purchased as a second hand or third hand, and they use them nowadays to, publish things on social media. So this is an example coming from the real world, and it's not something theoretical. There are companies who do support that kind of mindset when releasing mobile applications. One interesting fact about data centers that we experience while working with customers is that in the data centers, we tend to find many servers that someone turned on to run an experiment some months ago, and after that, it was forgotten. And nobody actually uses it. But these servers consume electricity, and they consume electricity without anyone using them, without offering any useful work. Excuse me. We also call these servers zombie servers. And according to some research, 25% of the physical servers in data centers are zombie servers. Therefore, these are servers that are not used, whereas 30% of the virtual machines running on top of these physical servers are also unused. From our experience working with customers, we observe this most frequently with the development and testing environments, where developers have more freedom to spin up new servers when they need to run experiments and then tend to forget them. Whereas in a production environment, where things are more strict and more controlled, we tend to see less of that observation of having zombie servers that nobody uses, but they still consume electricity. This is a graph from an actual customer showing the carbon emissions on a daily basis. What we did with that customer is we recommended that they automatically shut down the development servers during the weekends, because nobody uses them. They don't have any developers working during the weekends. And after they done that, we observed a 12% reduction in the carbon emissions. They spent only 5 minutes to automate the process of shutting down their servers during the weekends. But thanks to this simple action, they achieved a significant reduction in the carbon emissions. Therefore, a lesson learned is that even simple actions as this one of shutting down the servers when we don't need them can have a significant impact on, on reducing global warming. One more practice we usually apply in the green software space is rescheduling compute-intensive jobs so that these run when the sun shines and the wind blows. I'm sure many of you heard batch jobs, the term batch jobs. Most banking institutions run some batch jobs late at night, usually after midnight, to calculate different things related to the financial results of that banking organization. However, if we look at it from the sustainability perspective, after midnight, most electricity comes from power plants that burn fossil fuels. We don't have any energy coming from the sun, not after midnight. Therefore, one common practice that we apply is rescheduling all these batch jobs so that they run when we have abundant supply of green energy in the power grid, preferably early in the morning, or in some other cases when the wind blows and we have wind energy supplied into the power mix of the power grid. For example, YouTube, whenever someone of you uploads a new video to YouTube, there is a process running in the background that takes the audio and converts it into text that is used in the captions, in the subtitles of that video. This does not happen synchronously though. After you upload a video on YouTube, it waits until there is green, clean energy available, and only when the sun shines would it run this speech-to-text process to create the captions for the videos. In a similar fashion, whenever we run AI workloads, whenever we train AI models, we can schedule these to run when the sun shines and the wind blows. And that's something that we do because we want to reduce the carbon that is being emitted into the atmosphere from these compute-intensive jobs, such as training new AI ML models. Do you have any questions so far? If not, it's time for a quiz. You can provide an answer in the chat if you want, or if not, you can just think about what the correct answer could be, and then I will, after some time, I will provide you the right answers. So first question, by 2040, ICT emissions, this is the information and communications technology, this is our digital world. So ICT emissions are projected to contribute approximately how much of the total greenhouse gas emissions? Is it A, 5%, B, 14%, C, 19%, or D, 25%? And the right answer is 14%. However, as I told you previously, this comes from a research that was published before the introduction of generative AI like ChatGPT. So the right answer could also be C or D, depending on how that goes, on how much we adopt generative AI in the following years. Second question. What is the average lifespan of consumer electronics before they become e-waste? Is it A, about 2 to 3 years, B, about 3 to 5 years, or C, about 5 to 6 years? And the right answer is A, 2 to 3 years. However, we should all try to keep our devices longer. This is really the most critical part, the most critical impact of our digital world. And we can all help prevent the climate change by keeping our devices longer. Third question. Streaming Netflix in standard definition rather than high definition would lower the carbon footprint by how many times? 2, 5, 10, or 20? And the right answer is 20. Also, an interesting fact, if you remember during COVID, when all of us were working remotely from home, the networks in worldwide couldn't keep up with the increased demand. That's why Netflix had voluntarily downgraded all their streaming to standard definition, because they also understood that, by reducing the definition, downscaling it to standard, then they would contribute to reducing the traffic of data sent over the network. Fourth question. According to an MIT study, turning off the camera during a video conference saves carbon emissions by 96%, 67%, 25%, or 0%, no difference. What do you think? And the right answer is A, 96%. Of course, when we work remotely, it's a nice touch always having the camera connecting with others, but that's something useful to keep in mind. When not needed, then it's a good practice turning off the camera during a video conference so that we save carbon emissions. Fifth question. By how much can the dark mode in web applications reduce the energy consumption for OLED screens at 100% brightness? Is it 10 to 20%, 30 to 40%, or 50 to 60%? And the right answer is B, 30 to 40%. I'm sure you've seen in more and more websites, some icon that allows you to toggle that application from the light mode to dark mode, where everything becomes black and gray. This can actually reduce the energy consumption, which can be quite useful, especially for smartphones and tablets, where we want to prolong the battery life of these devices. Therefore, again, one thing you can do when working for financial institutions, for banks, you can influence your organizations to adopt dark modes for your applications, which could significantly reduce the electricity consumption of devices that have OLED screens. Do you have any questions right after the quiz that you would like to ask? We have 5 more minutes to go for the session. If not, I'd like to highlight here the Green Software Foundation. This is an organization that Accenture co-founded 3 years ago together with Microsoft. And when we started, most people were not aware of the environmental impact of our digital world. And what we've envisioned then is that to be able to tackle that problem in a timely manner, we need to collaborate with all the key players in our industry to create new standards. So one of the most basic things that we couldn't do at the beginning was to measure the carbon emissions of software applications. There was not any methodology, there were not any tools that would help us calculate the environmental impact of software applications. What we did is that we collaborated, we onboarded some of the biggest players in our industry, and collaboratively working together, we created the software carbon intensity, which became an ISO standard in March 2024. This is what everyone uses nowadays, that standard to calculate the carbon emissions coming from software applications. You can see here in the steering members that we have UBS, which is a bank, as you all know, because as we previously hinted, most of the carbon emissions coming from banks are from their data centers. Therefore, by joining that Green Software Foundation and applying these practices, banks can significantly reduce their carbon emissions. Here you can see more members of the Green Software Foundation. There are more banks. So for example, here we have Goldman Sachs, we have HSBC, we have Intesa San Paolo, we have MasterCard. So there are quite a few players from the financial services industry who show a genuine interest in tackling climate change, and they all work with us. We all work together under the same roof, under the roof of the Green Software Foundation, to raise awareness and provide the tools and standards we need to address the climate change. Thanks to the work we've done in that space, Accenture has been recognized as the leader in IT sustainability. We received that recognition from Forrester in 2023, and we received that recognition thanks to all the thought leadership we published, thanks to the assets we created and the work we've done with our customers, helping them to measure and reduce the environmental impact of their digital systems, of their IT systems. I want you to remember two things out of our session. There are ways, many ways in which you can contribute to tackling climate change. If you can only keep in mind two things, the first one is to keep your devices longer, keep your smartphones, laptops, tablets, more than 4 or 5 years. You know, it doesn't help if we change them every year to get the latest and greatest models. And the second thing we can do, if you are responsible for operating servers in a data center, you know, you can schedule this to automatically shut down during the weekends or holiday seasons when you don't have any developers working there. And you can do the same for your computers at your home or at work. Always make sure that you turn them off when you don't need them, because these consume electricity, which is an invaluable resource. And especially due to the lack of energy nowadays, you can make a real difference just by shutting down your electronic devices. Thank you, everyone, and I'm open to any questions you may have about digital sustainability.
Thank you so much, Ioannis. That was really, really interesting. And I think it's opened our minds to things we didn't really know about. Although there's lots of discussion about sustainability, it very seldom kind of comes home to us as individuals that we can do something about it. And I was really taken by that. You'll be glad to know that my smartphone, I think, is 6 or 7 years old. I was delighted to hear that. But there's enormous pressure to change your phone. And I'm sure parents will be delighted too when they're talking to their children and so on. But I think you're giving us an understanding of how environmental impacts works in our digital world is really important. And before we talk about some of those issues, there's a number of questions here. The first one, allowing older operating systems to run our apps. Is there any greater cyber risk in doing that? And that's, as you know, is a big issue about cybersecurity. And the idea is that if you upgrade, you know, it'll be better.
Yeah, so the recommendation when keeping devices longer is that we also influence organizations that provide that these operating systems to continuously update them. So back when I was presenting, I mentioned that my application, my mobile phone didn't receive any software updates. I agree that this can be a security risk. If I kept my mobile phone, that could also be open to cyber attacks. So I agree that one action is from us to influence our organizations to release mobile applications that support older phones, but this must be combined with influence to organizations that release updates to these mobile phones to continue providing these updates. So this could be influence, to Google, who releases Android, or to Apple, who releases iOS. And we can also do that as consumers by choosing operating systems and companies that have commitments to support these operating systems over a longer period of time. If I recall correctly, for example, there was a model released by Samsung last year where they made a public commitment to support this over a period of 7 years, if I recall correctly. Therefore, again, I agree to your point that it's not a good security practice to keep all devices that are not updated. However, again, we can influence this as consumers by choosing companies that show some commitment in maintaining their devices over longer periods of time.
Thanks very much for that. And one of our attendees, Peter Forsey, has added to what you're saying that would it be best for organizations to review their entire server infrastructures, as many systems are time bound. For example, finance and HR systems are rarely, if ever, used overnight. An organization could categorize utilizations and periods of zero use where servers can be shut down. So an additional benefit of this is improved security, as running processes are automatically terminated. So, that's a suggestion for the whole organization, Janice.
Yeah, that's a very good point. And it reminds me of a case of a banking organization that had a system dedicated to running the end of year report. It would run only for a couple of days after the end of year, but they still had it powered on the whole year. So that comment resonates with me because, a system may run only once a year to generate an end of year report.
And then I suppose following on from that, there's a question about, are there problems turning off servers? Does that create a problem of its own during the weekend or overnight?
What kind of problems?
I think it's very open, yeah.
Yeah. So there are some minor trade-offs that one needs to consider. So, for example, you need to spend some time to automate the process of turning on and turning off the servers. Or there may be a warm-up period. The servers may need to run for an hour before initializing some processes and being able to serve customers. So in that sense, there could be an overhead which would require you to start the servers, for example, 1 hour before you actually need them. So this is some sort of a trade-off, but still, turning on the servers 1 hour before you need them is less than keeping them running 24/7. Yeah.
And following on from that, is the transfer to digital technology a net gain in aiming for carbon emission reduction, or has it just moved to compound the issue to a different area? And should data centers be operating on a different grid to residential, or does that waste more electricity if households and business typically use electricity at different times?
Yeah, so I think it contains many questions, so I'm not sure where to focus. One thing we proposed earlier is to schedule jobs when we have abundant supply of electricity in the grid. This usually happens with renewable energy. So in the morning, you can even have more electricity than homes and data centers can consume.
Yeah.
And as a result, you just throw away that energy. There is no practical way of storing that electricity. So although I'm not really answering your question as to how to separate houses from data centers, the practice we recommend is to shape the demand by shifting the execution of batch jobs so that we don't put too much pressure on the grid. This could be one more concern. When there is increased consumption from the houses, then we could not schedule any jobs at these periods of time, but we could shift them. However, this would only work for jobs that can be delayed. Not every computing job can be delayed.
I suppose what you're saying, though, is in a way, in terms of both policy and regulation, we need to better understand how these data centers are working and maximize their use so they're not emitting, having as many emissions. So it's rather than just see them as generic centers, to really have a better analysis, which I'm sure people have, but to then do something about it in terms of admissions. There's Maya Scenario says there's a move to saying what you had said about move to Apple and Samsung to make sure that software updates are backed up for compatible models. So I suppose the real issue is that influence on producers of devices, that makes an impact too, doesn't it, really, if that will happen? There's a number of people who have said, listen, thank you very much for excellent presentation and lots of interesting facts to help put the topic in context. So thanks very much for that.
Yeah, thank you for your feedback.
Yeah, this Oksana Gu says the best presentation ever. Loved examples. And I suppose the real issue and the question there that you've raised is that individuals can do that, and in your experience can make a difference. In your experience, what's the best way for individuals and organizations to set out an action plan that will actually have an impact, to involve people with that? How can you start doing it in a systematic way that actually will have a real impact?
Yeah, that's a good question, but the answer will be quite long. The short answer is that although we talk about technology, we address it as, this is a more complex issue. It starts with people. In Accenture, we started with people, training people, raising awareness about the issue and the things that they can do. We created role-based training. Therefore, the first and most important aspect is people, training people and creating a culture that sustainability is a first-class concern. Then the second thing is processes. We changed all the processes to embed sustainability. Whenever we kick off a new project, we have processes that address sustainability from the start. And then the third thing we did was develop tools or use third-party tools that help us, again, embed sustainability into the solutions that we provide. So it's a three-dimensional problem of changing people, processes, and the tools we use to do our daily job as software engineers, as software architects, and deliver IT systems for our customers.
And Graham Farley has asked in an interesting question, how many individuals would it take to take these actions in order to offset the emissions from a single average data center? It's a difficult one, Ioannis.
Yeah, it's a difficult one. I would say it takes only one, you.
Yes.
If you, me, each one of us just takes these two simple actions we mentioned today, keeping our devices longer and shutting down our digital equipment when we don't need them, then we can make a big difference. In the very end, these data centers run our own applications. Whenever we watch videos on YouTube or whenever we watch movies in Netflix, these consume significant amounts of electricity in the data centers and the networks. So it's not someone else using the data centers. In the end, it's me and you.
Yeah, I think that's a really good note to end on, that it is about individuals. It is about all of us taking that that account of digital sustainability, whether it's financial services or other areas. And I think that idea, keeping your devices longer, isn't that simple, and shut down unused services and computers at night. Many people just leave them in automatically. But I think the overall points that you've made, that it's really about people, not processes. It's about a culture. It's about sustainability. And, you know, then looking at changing processes and enabling people with tools. And I suppose that really puts culture at the center of it. And, you know, with ESG, you know, policies and so on, this is a really practical way to do something about it. And I would hope after your lecture that those who've attended will start talking within their organizations, and perhaps more importantly, you know, turning off those computers at night, keeping their devices longer. So I think you've really given us enormous food for thought, great examples, tremendously presented. And we thank you very much for that. It's because part of this series on AI is, and its impact, is to take the fear out of these technologies and to see that the individual themselves can take control, and you can do it one step at a time. I thought your answer to that question from our attendee, Martin Farley, was very good. It's one step at a time. It's each individual. So thank you very much for that. And thank you again for giving us your time. And I'd like also to thank Megan on the production side and our colleague Claire, who together planned this webinar. And we look forward to seeing you next Friday with Professor Martin Curley on AI and health. And he's a hard act to follow now, I can tell you, after Ioannis. We really appreciate it. And thank you again. And we look forward to seeing you next week. And maybe, Ioannis, we might see you in Ireland in the near future. Thank you very much.
Thank you very much.
Thank you so much. Thanks, Ioannis. Thanks, Joyce, and everyone for joining. Take care. Bye-bye.